help me welcome Russ Miles.
Thank you. Good morning. Can you hear me okay at the back? Everyone at the back, wave your hand if you can hear me. If no one waves, I'll know you really can't. You lucky people if you can't. Okay, yes, so I'm going to start today with a song, because that's how you start a Friday. Please indulge me for all of about five minutes. You're very lucky. I have another version of this talk, and the song that I use is Bohemian Rhapsody, which is a little bit unfair for a 30-minute talk to have a good, what was it, about 13, 14 minutes worth of song. So, yeah, you're very fortunate that you don't have that experience, but let's get going. So roll on. Seems to be working, for once. One second. Does anyone spot the deliberate problem? You see, we're talking about event-driven systems today. And I have introduced, deliberately, latency. Thank you, GarageBand. Give me one moment to remove said latency from my system. You know it's live this way. That's better. There's nothing like hitting a chord and then waiting. What was the thing earlier? The little spinny dial. That's what we should get for every single chord I was trying to play. That's better. Now we're in business. All right, excuse me. I've got to do it from the beginning, otherwise I have no idea where I'm at. just wakes us up. Now you can see me editing it. That's great. Yeah, let's put that down for a minute. And hit that there. Cool. Okay, right, so let's get to the serious stuff. Or more serious stuff. So that's pretty serious, but this is where the serious stuff kicks in. Okay, so my talk this morning is hopefully going to set the stage for some of the challenges that you're going to face when doing microservices, particularly if you have that interesting title of being the architect, whatever that really means. Does anyone know, I want to shout out, the biggest challenge, the single biggest challenge of being an architect? The biggest, by a long way. What's the one thing that happens to you as an architect?
Tell the future.
You can tell the future? Yeah, you need a crystal ball for everything. Yeah, that's part of it, there's no doubt. Yes, you have to see the future. You get ignored. You have fantastic ideas, like event-driven microservices. And everyone says, yeah, that sounds good, but that's overly complicated for our needs. And I found this over and over again. Every time I approached an organization and said, you should consider maybe looking at asynchronous event-driven systems as a way of introducing scaling, redundancy, fault tolerance. Those words made sense, but they were very quickly ignored. So I'm going to give you a superpower this morning that stops you being ignored anymore. Quickly introduce myself for those of you that don't know me. This is how I fantastically believe I am. I think I'm a software philosopher. Don't really know what that means, but it sounds cool. And I live and exist on Twitter. I do apologize if anyone wants to follow me on Twitter. I do binge tweet. I won't tweet for a week, and then suddenly you'll have nothing but me for about half a day. I apologize in advance. Some of the reasons, though, that I binge tweet are that I have just recently, in the last few months, completed a tour around America where I did this talk, very similarly, all the way across the States. I did 6,500 miles on a Harley Davidson, and pretty much everywhere I stopped, including the desert, I did a talk. After that, to relax, I did a ride from Kathmandu to Everest Base Camp, as one does, to relax. And the nice thing about that is, in many ways, the analogies to software development were profound. Number one, that's pretty much what a roadmap looks like. And although we knew what we were aiming for, and that's a real picture, by the way, that was one, I didn't take it, but someone else on the tour took that picture, but a pretty amazing view. That's what we're aiming for, that's the beauty of what we're building. But what you don't see in the background is that, which is the bathroom of the place I was staying at when I had the view of Everest. Okay, so last thing to introduce myself. I am part of the Chaos Collective. Yes, we're not part of chaos theory. We're about chaos engineering. And this talk is going to explain how chaos engineering helps you stop being ignored as an architect, particularly when you're considering some of the more complex facets of frameworks like Axon. And I should point out, as part of the collective, we're self-aggrandizing governors and helpers and supporters of what the technique is supposed to do. So I will try and get rid of some myths around chaos engineering in a minute, because you'd be tempted or forgiven, perhaps, for thinking that chaos engineering is about breaking things. It's not. Sorry. It would be cool if it was. If you were in any way a sadist, that would be chaos engineering for you. But unfortunately, that's not what it's about. So yes, as an architect, we tend to be ignored. And I would have this over and over again, where I would say, look, let's consider these non-functional concerns. And then everyone would nod, wisely and ignore me. And the reason I used to talk about these things is that the main goal of everything I'm doing is about reliable systems. Now, reliability, I think, is a measure of what your customers or your users want. As a user, I want your system to be wonderfully feature-rich. I also want it to always be there, which is a problem for you. It's a problem for us in the industry. We have two opposing forces: continuous innovation and change, coupled with it's always got to work. These two things don't coexist very easily. And particularly where our systems become a lot more complex or complicated. What we need to aim for, and what is the hardest thing as an architect to get anyone to listen to, is this idea of resilience. You're building resilient systems. And when I say system here, I have to be a little careful. I'm not just talking about the technology. I'm talking about the whole system, including the people, the practices, the processes that surround it. So when you consider the whole socio-technical system, it's a minor miracle that production ever works. It is constantly under attack by your users and you. Okay. Someone I admire greatly is John Allspaw. He is in this space around resiliency, and he tries to clarify what it means. If you're building systems where there's a lot of redundancy in there, there's some HA capabilities, replication, distribution, then you've got a robust system. It's a system that hopefully when it gets shocked by users, which it always does, it may carry on ticking, which is robustness, but not resilience. He characterizes resilience as being when you have people involved. So when I talk about chaos engineering today, chaos engineering is far beyond the tools. It's about how people think about the system. It's how we approach the system. So we're looking to build resilience in. The fantastic thing is that frameworks like Axon, and particularly event sourcing, these are mechanisms for improving potentially the resilience of your system. But back to our issue of the day. As architects, you can say this until you are blue in the face, but you will be ignored. So chaos came from a desire actually not to be ignored. The written history of chaos engineering goes a little bit like this, which is that, I'll paraphrase for you, smart people at Netflix did something, was cool. But I have an alternative to where this came from, which I think is a better example because it talks more about people. My alternative involves this particular lady here. Does anyone know who that is? No? Fair enough. It's Margaret Hamilton. She was part of I think she was lead on the software project for the Apollo program. And the cool thing about Margaret is that I wanted to say she's the first chaos engineer, but I can't do that because the first chaos engineer was her daughter, Lauren Hamilton. You see, Margaret used to get criticised for bringing Lauren into work while she was at NASA. And you can imagine NASA, this is in the days where NASA made IBM look relaxed and cool. We had the NASA folks turning around and saying, what is this lady doing? By the way, the ladies were doing the software because the men didn't want to. How pathetic is that? Anyway, did a fantastic job, as it turns out. And Lauren was brought into work because Margaret wanted her daughter with her. And this was all against the rules, I believe, of the state at the time. Anyway, she came in, and as like any mother or any parent, there's quite a few parents in the room, you figure out a way to entertain the kid whilst you're doing some work, right? And so what she did is she gave Lauren a tool, a toy to play with, which was the mission simulator. How lucky as a kid is that? And the next thing that Lauren did is break it. That's what kids do. That's what chaos engineers also do sometimes. What she did is she caused the mission to fail by flushing out all of the navigation information from the system. But the interesting thing about the story is not that she did that. It's Margaret's reaction to her doing that. You see, Margaret went to the bigwigs at NASA and said, we have a problem here. If this combination gets hit, production dies. I mean, she called it a spacecraft, but let's call it production for a minute. Production dies. Okay. Their reaction was, don't worry. Our astronauts have got the right stuff. They're perfect. They'll never hit that combination. Ever. The very next mission involved taking this wonderful photo, which would never have been captured if Margaret had followed the response from the management in NASA. You see, she came up with some ideas about how they might overcome this problem if it occurred. Now that she knew an issue could occur, she had some empirical data to suggest it would, which had come from her daughter. Margaret could then prepare for this case. That mission, not long into takeoff, these super well-trained astronauts hit that key combo. and flush the navigation information. It's not even just about losing the photo. It's about losing the spacecraft and the people in it. It was that level of catastrophe that Margaret was prepared. Okay, so bringing it back down to earth, literally, what's the problem that we've created? Well, if you're doing microservices in any sense, and I'm not going to get into a debate about what is or isn't a microservice, I think we've done that to death. I don't care how big your services are. What you get out of the system is much more important. And as mentioned earlier, your system should be evolving as quickly as possible. That's why we did microservices. The size of the service wasn't the biggest deal. But it does cause challenge. And I'm going to abuse the Cynefin system to explain that challenge. Number one, you are not down in the bottom right quadrant unless you are paid to do Hello World. And if you are, well done. I believe some of us that work on frameworks to get paid to deliver Hello World examples. Isn't it great? That's the only time where I think you're down in simple. And the attractiveness to the simple quadrant is that there are best practices down there. I can say to you, just do this, and you'll be better. But you're not there. You probably think you're up in complicated. There's lots of moving parts. And they have to talk to each other, and that can be a challenge. And you're starting to get a flavour then for the amount of failure that might be in there. And complicated isn't so bad because there are good practices. I, as a consultant, can turn around to you and say, do this, you'll probably be better. That's not bad. But I've got bad news for you. You're building distributed systems, potentially asynchronous distributed systems. And you're at least then in a complex world. In a complex world, there are no good practices. There are emergent practices, there are emergent needs, and the problem is they only emerge over time. They are the sorts of things that an architect considers, and they only happen after time. Everything looks simple and straightforward until you try and run it in production, and then it becomes not so. But I've got more bad news for you. If you're building event-driven microservices, which evolve quickly, which was at least part of the point, then you are in chaotic. Chaos is not where you'd like to be, normally. The problem with chaos is if you're going to find better in a chaotic system, you are surprised by it. That's what novel means. So wouldn't it be great if we had a technique that engineered us out of chaos? That is what chaos engineering is. But there are loads of attack vectors on keeping us in that chaotic area. These are the things dragging us back. This is the inertia. You're probably familiar with infrastructure concerns causing you problems. Virtual machines dying, machines themselves dying, networks dying. That all goes down in the infrastructure area. Weirdly enough, it's probably not the biggest cause of problems for most medium-sized systems. But it's where everyone focuses first. When they see the chaos monkey, they go, right, it's all about destroying virtual machines. That's all it is. No. You see, there's lots of other places where things go wrong. There's the platform, whatever you call that, whether it's Kubernetes, whether it's Cloud Foundry, whether it's running on any of the different flavors of systems out there. If you're running on a high level of abstraction, you've got a platform of some sort. And the platform itself can let you down. So that's an area of potential failure. Then there's the code you write. Sorry, you're not perfect, neither am I. We're all going to write code that can bring the system down at some point. And then last of all, the single biggest cause of failure in any system, people. Us. The people, the practices, and the processes that surround it. So, back to our need as architects. Wouldn't it be great if there was a way of being proactive, preemptive, about failure in our systems, about these non-functional concerns, which I hate the term, by the way, non-functional. Non-functional is the stuff that makes the functional work. Without the non-functional, it's not working at all. So for me, it's all functional. Chaos engineering is going to help us with this. So let's get you up to speed. Number one, I want you to have a mindset. This is a good phrase for what a mindset like this should look like. Never let an outage go to waste. This is kind of reactionary, but it's a good starting point. The idea is when an outage happens in your system, you are going to want to learn from it. It's not a question of saying who is to blame. I did this talk before I did one of my tours, and I asked the room, can anyone here share with me a failure in production? There was a wonderful, beautiful individual who shot his hand up, and before I could stop him, he was up on stage with me. Now, I subscribe to the Keith Richards school of stage invaders, which is try to kill them. And he was lucky, because he came straight up, and he was bigger than me, so it wasn't going to happen. But so he stood there, and he said, "It was me." And I have never seen such a confession. He said, "I was the one that deleted the master node on a high-performance computing cluster for my university. Weeks of research was lost. I did it." I realised at some point in that no one else knew he was the one that did it. And I feared for his job. But the point here is, as a chaos engineer, you don't look at that person and blame them. There's something else gone wrong here. They're surrounded by a system, and the system has let them down. We are human. We tend to make mistakes all the time. And he had. Owning up to it's good, but looking way beyond that responsibility is the important part of the mindset of chaos engineering. We're trying to look at how the system could improve. Just to finish that story quickly, what he'd done is he'd written a command line which had taken down that master node. He'd been trying to take down a simple admin node, but he didn't. In that command line, the difference between success and catastrophic failure was one character. One. So don't tell me the person's the problem. The problem here is that when we dig deeper and deeper and deeper, there's got to at least be some suspicion around how we're naming stuff. Okay. Chaos engineering, as I said, is more about, though, being a pre-mortem sort of attitude. It's part of the game to learn from outages, but it's better to explore weaknesses in the system before the outages occur. And that's what chaos engineering is really all about. It's when you're trying to explore and surface weaknesses in the system before they happen. For that, we need a process. Good news. This process will not be, hopefully, too dissimilar from what you've seen before, because it's basically the scientific method. Now, anyone here a scientist? Okay. Who did a computer science degree? See, lots of... Isn't it amazing how many computer science degrees we do, and we never do science after that, or anything misconstrued? Good news. Chaos engineering is scientific. Now, as a scientist, what's the very first thing you do? Well, you create a hypothesis. No, you don't. I know, I've got plenty of great scientist friends, and they'll tell you the first thing you do is you poke the thing, and you're surprised by what happens. Whether it be a theory, whether it be some system, whether it be a Petri dish, we poke it and go, huh, that's not right. That's fine. Then you step back and go, I have a hypothesis for this. So when you're doing chaos engineering, what normally happens is someone goes, what if... Ooh. Yeah, that's not good. And you build a hypothesis around that, and you go, well, the hypothesis of chaos engineering is the system should survive. Right? Everything should be fine, even if this happens. And the if this happens goes into your method. So you then communicate with your team. This is incredibly important. I'll get back around to this in a bit. Chaos engineering is collaborative. You don't do it in isolation. If you are in any way inclined to write a chaos experiment, run it against somebody else's system on a Friday, around about 6 p.m., then don't do chaos engineering. You are a sadist, not a chaos engineer. Step away from the keyboard. Okay, so you communicate with the team. Everyone should know that chaos is coming. It's not a surprise. And everyone should be bought into what we might learn from this, because you're looking for proof of there being a real weakness before you try and fix it. You can then look at the results after you've done an experiment, and then you can increase the scope. Scope's an interesting one. Don't be the person that phoned me up and said, we ran Chaos Monkey in production. Killed everything. We knew it would. Then why run it? If you know that what you're going to do will bring your system to its knees, once again, you're not learning, you are back in harming things. You know, you shouldn't be allowed to own animals at that level. We start tiny when we do chaos engineering. We start with one small experiment that says, what if this? And then if the system survives recognisably, normally, then that's great. We've learned the system doesn't have a weakness, and then we can choose to increase the scope. But we don't start huge, because you will never be allowed to do it again. I actually have had customers and clients turn around and say, we did Chaos Monkey in production, now the company doesn't like chaos engineering. And I get it. Why would they? You have to start small. And then the interesting one is the last point here, because there's a lot of chaos engineering tools out there, and people get really into the tools. And I have my own tool sets, an open source project as well. But most of your chaos engineering work starts with your brain. And you work through it and get your experiments manually. And then you look to automate towards the end. Then you can pick up things like the toolkit and go with that. Okay, ethics. I've mentioned this, I've alluded to this. This is the single biggest and most important thing you need to know about chaos engineering. If you get this wrong, you lose. As chaos engineers, you must have skin in the game. You cannot be someone who sits back, hurts the system, and then waits for others to fix it. You have to be part of the downside. You have to be part of the effect of what you've done. You need to be working with everyone. In Netflix, the Chaos Engineering Group, that's now renamed as the Resilience Engineering Group, they are a service group. They support and serve the teams that are exploring weaknesses in their systems. And that's where you would need to operate. I have seen people attempt to do it the other way, which is to say, I have a group of people that just hurt systems for a living. You won't win that way. Good news though, chaos engineering is simple. There's only two main key practices that come under just the discipline of chaos engineering. So there is no need, please, for any certification program. If you're in any way inclined to create a chaos engineering certification program, I will find you. Things will not go well for you. I'm small, but I'm strong. Anyway, so these are the two things you need to worry about. Game days and automated chaos experiments. Game days are the most fun thing you'll ever do with your system. Go back to that thing about architects being ignored. Nothing helps you not be ignored like getting all the teams together and going, right, today we're going to change some condition in production that we all agree could happen, and we're going to see how we deal with that. They will suddenly feel the angst. You can even do this in staging, and they will still learn from it. I do game days quite frequently. I facilitate them, and I love doing them, but they are very dangerous and powerful things. You have to be very careful. For example, I did a game day where I suspected that there was a weakness in the system. The weakness I suspected is that the playbooks were stored in a room with a door, with a lock, and with a key. Those playbooks were the essential recipes for overcoming system failure. And so what I did was I organised a game day with the teams, and I said, right, in this game day, we're going to cause this sort of problem in the system, and you're going to try and detect where the problems are, and you're going to try and fix them. All good? Great. Let's do it. Now, a little warning. If you're facilitating a game day, don't go and get a coffee. Because I did. I got the whole game day started. Something was broken in staging. They started working on it. I went off and got a coffee. When I came back, I had to physically stop them breaking the door down on the room with the playbooks. It's amazing how emotional it gets. There's a lot of pride on the line when they do this. And so you have to be there as a supportive influence on them. Okay. However, game days are expensive. They involve a lot of your time and the team's time. So if you want to continuously explore and look for weaknesses in the system, then you'll move on to automated chaos experiments, because then everyone doesn't have to stop what they're doing to do these things. Okay, chaos engineering though. When you walk out of here and start talking to your companies, as I hope you will, about potentially looking at chaos engineering, here's some hints about how to overcome those that just hear the term. Number one, don't use the term. Now, there are some diverging opinions on this industry, and as chaos engineering becomes more mainstream, I think we're getting over the fear of the term. But I certainly a few people out there that I still meet where you say to them, we're going to do chaos engineering, and they say, no, you're not. We've done chaos. We were part of the financial crash. We don't need any more of that stuff. And I understand that. I understand the misunderstanding of the term. So I drop it. I tend to use a different term. I'll give you this term now. I do continuous limited scope disaster recovery. Exactly the same thing. But it sounds like something that will get a budget. It works. Don't talk to people about how you're going to break things as well. That's not your first opening gambit. You don't walk up to the teams and go, do you know what we're going to do? We're going to break your virtual machines, because they'll say don't. So tend to start with the conversations around production incidents. What happens if this goes wrong? Has this happened before? Are we any better at this? What could we learn about our system and improve on? That's the game. We're in a learning loop. That's what chaos engineering is all about. Okay, so just to hammer this home, there are some rules of Chaos Club. Okay, please follow these rules. First rule of Chaos Club, we've already heard it. Don't talk about chaos. It's continuous limited scope disaster recovery. Start there. Introduce chaos engineering later when people are comfortable with it. Number two, it's about learning, not breaking things. We're trying to improve across the entire socio-technical system. How do we deal with the weaknesses that are going to be there? How do we find them before our users do? Number three, chaos should not be a surprise. Woo! I've broken things, good luck. Don't do that. And number four, this is more controversial. If you already know the system will break, don't do the experiment. You already have the learning. There is a few reasons why you might still do the work, but I would suggest that you fix the known weaknesses before you try and find the unknown weaknesses, which is the point of chaos engineering. So let's bring this back now to event-driven microservice-based systems. I've already mentioned that you have the challenge if you have an event-driven microservice-based system. Number one of the things that's the hardest thing to get anyone as a developer in a team to actually worry about is how to be a good citizen in production. What I mean by being a good citizen is that you have the right exposure endpoints to declare your health. You have the right touch points to go, I am okay in here, or I'm not. Getting people to understand why that's important is difficult. A small example of this is, I've lost count of the number of customers I've worked with where they said, how do we get the developers to do good logging? Easy. Make them read the logs. Do a game day where they have to understand the stuff they've deployed and are responsible for through their own logs. Those logs will infinitely improve when they are the consumers. That's what game days do. So that's one side of it. But the other side, and this is where anything that does event sourcing, as Axon does, becomes really interesting to a chaos engineer. Because one of the things you want is observability of the system. Chaos engineering normally goes hand in hand with good system observability. Just to make sure we all know what observability is, because there are lots of confusing definitions out there. We're good at that. Observability for me means I can debug it when it's running without changing it. I can debug my system. Not just what I run locally, but actually on production. So great system observability is important to chaos engineering, because if you do a chaos engineering experiment, even a game day, the first thing you'll find is you want to debug the system. You need to figure out what went wrong. So immediately you're inclined towards better observability. One of the things that's a great feature of event sourcing is that you have a system of record. You actually have the record of what happened when. It's not just good for auditing and proof to organizations that are saying, what did your company do recently? It's going to be important to you as responsible teams looking after your stuff in production. Okay, and that's just two of the things that matter the most. If you want to know more about what it matters to event-driven systems, come and find me later on. I'll probably be sitting with a guitar on one of these couches. Okay, just to finish, I have a confession. No talk can be complete without a picture of the Pope. My confession is this. Earlier on in this talk, I said that you're working with complex and chaotic systems. And by definition, you don't have best practices and you don't have good practices. I lied. For once in my career as a consultant and developer, there is a best practice. And for me, it has become chaos engineering. It's the only thing I can say to you in all of the complex, necessarily complex, essentially complex systems that you can build with all that power of speed of change that you're going to get. It's the one technique I can say, just do it. A small amount of it, manually, as a game day, whatever works for you, but do it. If you care about the reliability of your systems, and therefore you care about your resiliency, this is a tool for you. Just do it. Okay, got some links for you that I'll tweet out later if anyone follows me on Twitter. But that's all I have for you this morning. I'm a little bit over time, but I think I've kept reasonably well in. Can I ask for any questions now? Do I have time to ask for a couple of... Anyone have any questions right now? Any burning ones? Not at this point. Okay, if you have any more throughout the day, come and find me. Like I say, I'll be chilling with a coffee somewhere. I have a workshop later on today. I believe you're all signed up for workshops already, but I have a workshop on chaos engineering later on. We're actually going to do some. And then I'm going to be part, I think, of the panel discussion later. So if you have any random thoughts or you just want to throw things at me, I'll be on that panel discussion as well. Thank you very much for your time this morning, and have a great day at the conference. Enjoy.